Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about a few practice examples on predicate validity. In our previous classes, we clearly discussed about universal and existential specification generalization formulas. Please watch those classes and come back here. We are going to use those formulas and we are going to use the inference formulas which we discussed in our previous classes. Coming to today's class, we need to show that there exists x, m of x follows logically from the premises. They are going to give some premises. So the similar examples we have done in our previous classes on proposition logic. There we don't have the concept of a universal and existential quantifier concept. And the statements are written directly using the variables. Here using predicate variables we are writing the statements. So most importantly, universal and existential quantifiers are not there. So here we are going to solve similar examples using universal and existential quantifier statements. That is the only difference between these examples and the one we have done previously. So coming to today's examples, there exists x, m of x follows logically from the premise. These are the premises, one premise, second premise. So from these premises, we need to identify this is valid or not. Means the meaning of this is this statement and this statement is true. If this is true, can you say that this statement is true or not? So coming to that, how we are going to solve this? Take the second premise, there exists x h of x. Using existential specification, there exists x h of x. This can be written as h of y. We are introducing a new variable called y, which is a free variable here. So existential specification using this. So why we can write this equation? These discussions made previously. We are not again explaining why we are going to write this h of y. So coming to the next one, take this equation for all x, h of x implies m of x. Using universal specification, we can write this equation in the form of h of y implies m of y. So from the given premises, we got the new equations h of y, another equation h of y implies m of y. From these two equations h of y implies m of y, this is in the form of p implies q, which is the inference formula 11. P comma P implies Q can be written as Q from I11. So P implies Q, we can write it as M of Y. Q means here M of Y. So from the given, so finally we concluded that M of Y. From M of Y, we can write it as there exists x M of x, universal generalization. So you can apply there exists x M of x. It's not universal generalization, existential generalization. So this is what we needed. This is what they have asked. There exists x m of x follows from the given premises. Yes, it is followed. So take the second example, one more example for better practice and for better understanding of universal and existential specification. This is very important example to understand. So there exists x p of x and there exists x q of x. Tautologically implies there exists x p of x and q of x. The same question can be asked in other way also. Show that there exists x p of x and q of x. This can be logically concluded by using the given premises. There exists x p of x and there exists x q of x. The same question can be written as implies p of x. So the other way we have to understand, using these two we need to conclude this one. So these are the two premises which we provided. From this we need to conclude there exists x p of x and q of x. Now try to solve it. So the premises are given as there exists x p of x and there exists x q of x. This is in the form of p and q. So from our inference formulas I1, P and Q implies, tautologically implies P, means P and Q means you can write it as P. Similarly, P and Q, you can write it as Q. So P and Q, you can write it as P. there exists x p of x. P and q, you can write it as q, there exists x q of x. So from this we concluded that there exists x p of x, there exists x q of x. Now we need to convert there exists x p of x can be converted as p of y using existential specification. Similarly, there exists x q of x can be converted into q of y. It is not valid. Q of y is not valid. Why? Because existential specification, there is a condition. If you want to write y here, that y variable should not be free in any of the premises that derived in our previous derivation. Here y is a free variable. You cannot use the same variable here. You cannot use the same variable. That's why we are changing the variable name. Instead of y, we are writing it as q of s. So now we derived p of y, q of s. So we cannot obtain the required. What we required, p of x and q of x, but we are having two different variables. We cannot derive it. So like this, you need to understand the formulas which we discussed in our previous classes. If you understand that, solving them is very easy. So this cannot be concluded. So now take the opposite of the second question. There exists x, p of x and q of x. This tautologically implies there exists x p of x and there exists x q of x. Can you show that? Yes, it is possible to show this. From this we need to conclude these two. This is possible or not? Yes, it is possible. You try to solve it by using the above examples and the previous knowledge. You try to solve this example. So for better practice, you do it. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.